Again on how to do dimensional analysis. I'm going to be using problems based on your worksheet number 2 that you did. I uploaded a blank copy to the Moodle in case you'd like to practice doing the problems again. For the most part, you guys did really well. The only reminder is to continue to say that you need to use units and you need to use conversion factors. I understand there are other methods. I understand you might think something's easier, but you will lose a significant amount of points if you refuse to use conversion factors. So, one problem that I know tripped people up was number 3. How many kilograms are there in 6,456 milligrams? Number one thing you always want to do with problem solving is just write down what you're given, right? This is what you know. And if it helps you to make your roadmap, you can write down way at the other end what you want to end in. Okay, that's your goal. You want to get from milligrams to kilograms. Draw your line because you use a conversion factor. And I know originally a lot of people's first question was, I don't have a relationship of milligrams to kilograms. How do I get there? Well, you're memorizing your prefixes, and one of the prefixes you know is milligrams to grams, and you also know grams to kilograms. So in this case, you can just use 2 relationships to get you to your final answer. Okay, milligrams goes on bottom, grams go on top, and for every 1 gram, there's 10 to the 3rd milligrams. I'm not done because I want to use kilograms, so I'm going to do another conversion factor of grams to kilograms. For every 1 kilogram, it's 1,000 grams. The way I've set it up now, my units cancel. Milligrams are gone. Grams are gone. And now we just have kilograms. That is why you need to use conversion factors. When all you do is write numbers, your units don't go away, in which case you have the same unit that you started with when you end. Okay. That's not what you want. You want a new unit, you have to show the conversion. So if you take this number divided by 10 to the 3 divided by 1,000, you will get a final answer of 0.0604. I have 6 kilograms. Sig fig wise, again, what goes in comes out. You don't have to consider your conversion factors at all in your final rounding. So since this one has 5 significant figures, your final answer will also have 5 significant figures. The other problem that I saw lots of difficulty with was number 4. How many kilograms do you have in a certain number of nanoliters? And I give you the density. So density allows you to relate mass and volume. In this problem, I'm asking for a mass, right, kilograms, and I give you a volume, nanoliters. The problem is the relationship I give you is in grams per mil. So somehow you need to get your volume measurement to milliliter, then you can use your density to get to gram, and then once you're in gram, you can get to kilogram from there. So there's just multiple steps to this particular problem. So I'm going to start out with my volume that I have, 1.54 times 10 to the 12 nanoliters. And again, I want to be able to get to using my density, but my density is in milliliter. So I've got to convert nanoliter to mils. Oops, sorry. You have a relationship of nanoliter to liter. You have a relationship of liter to mil. So you can do this in 2 steps. If you want to combine it into 1 step somehow, I'm fine with that, but I'll show you both steps since that's what you'll have memorized. The relationship you've memorized of liter to nanoliter is 1 liter is 10 to the 9th nanoliter. And then you can go liter to milliliter. For every 1 liter, that's 10 to the 3rd mils. So you can get an answer here and then use your answer to keep going. But you can actually just continue with your conversion factor here if you want to. Because nanoliter is gone, liter is gone. I'm in milliliter at this point when I do my calculation. Well, my density is also in milliliter, so I can use that to get to grams. Okay. The relationship of gram to milliliter was 5.33 grams per 1 mil. Now milliliter's gone and I'm in grams. If I just do this calculation, I would get my final answer in grams. Conversion factors are so great because it's so straightforward. There's no guessing here. Am I right in the right unit? Yeah, I'm in gram. Okay. That's not what you want. You want to get to kilogram. So you are going to have to use one more conversion factor. And I can't fit it on this board, so I'll put an arrow down here for you guys. You're going to have to multiply grams to kilograms. For every 1 kilogram, it's 1,000 grams. If you do this entire problem out, please note between each conversion factor is a multiplication sign, not an equal sign. These are not equalities. These are multiplication. This is a conversion problem. If you multiply it all the way out, your final answer will be this if you round it to the right number of sig figs. So this number has 3 significant digits. None of this needs to be considered, like the fact that this is 1 doesn't matter. And so this is then rounded to 3 significant figures. If you decided to do each of these calculations separate, meaning multiply this, get an answer, take that answer, multiply this, get an answer, etc., you don't want to round for your significant digits till the very end of your problem. If you round each time, you accumulate error. Okay. Try this whole worksheet again if you need to for practice. Do other practice that I have on the Moodle. Okay. Practice with answer keys. Do the book problems. You need as much practice as you can get to be good by Tuesday.